Next, we're going to take a look at how to simplify an exponential expression with an exponent of 0. Any real number raised to the 0 power is equal to 1, as long as that base is not equal to 0 itself. 0 raised to the 0 power is undefined. Any other number raised to the 0 power, your answer is 1. So for example, 7 raised to the 0 power, your answer would be 1. Negative 265 raised to the 0 power, your answer would be 1, and so on. If you have a negative exponent, to simplify an expression with a negative exponent, write the expression on the bottom of a fraction. And now it would have a positive exponent, and we could put a 1 on the top. For example, if we have x raised to the negative 6, we would have x raised to the positive 6 on the bottom of a fraction with a 1 in the numerator. Now, two questions that are very important to understand the difference. Suppose we have something like 7x to the negative 5 or 2x raised to the negative 3. These problems look very similar, but there's an important difference. In the first expression, only the x is raised to the negative 5. The 7 is not. So the 7 would be in the numerator and x to the 5th would be in the denominator. In the next expression, the entire 2x is raised to the negative 3. So the entire 2x moves to the denominator to the positive 3rd power with a 1 in the numerator. The 1 would stay in the numerator, and raising each part of that parentheses to the 3rd, we end up with 1 over 8x to the 3rd. Keeping these properties in mind, and the properties we learned earlier on in this section, if you would like to try simplifying the next few problems on your own, pause the video now and resume when you're ready to see the solution. Simplifying 2x to the 0, it's important to understand that only the x is raised to the 0 power. The 2 is not. So we would have 2 times 1. This is assuming that x is not equal to 0 itself. So our final answer, 2 times 1, would be 2. If we look at 35b to the negative 9c to the 3rd over 25b to the negative 7c to the negative 5, there are a few different ways of working through this problem. What I've found works the best for me is to take any expression with a negative exponent and write it with a positive exponent. For example, b to the negative 9, I would move it to the bottom of the fraction where it would be b to the positive 9. b to the negative 7 that was on the bottom of the fraction to begin with, I would move to the top of the fraction where it would be b to the positive 7. Now the c to the 3rd that was on the top stays on the top. It didn't have a negative exponent. There's no reason to move it anywhere. The c to the negative 5 that was on the bottom, we can move to the numerator where it becomes c to the positive 5. Now it's essentially like 3 separate problems, the numbers, the b's, and the c's. For the number part of the problem, 35 over 25, divide both parts by 5 to reduce, and we would have 7 over 5. For the b portion of the problem, we subtract the smaller exponent from the larger one when we're dividing. Taking 7 away from 9 leaves us with b squared in the denominator. On the numerator, multiplying c to the 3rd times c to the 5th, we add the exponents, and it would be c to the 8th. In our next problem, in the numerator, we need to square all of these parts. 3 squared would be 9. B squared is B squared. C to the 5th squared, multiply 5 times 2, you would have C to the 10th. In the denominator, 2 raised to the 3rd is 8. B to the negative 2 to the 3rd, multiply the outside exponent by the inside exponent, we would have B to the negative 6. C squared to the 3rd, multiply the outside exponent by the inside exponent, we would have C to the positive 6. Now the number portion of this one can't be simplified, so we'll leave it as 9 over 8. For the B portion of the problem, if you subtract 2 minus negative 6, that's like 2 plus 6, we would have B to the 8th in the numerator. For the C portion, you take the smaller exponent away from the larger one. Taking 6 away from 10, we would have C to the 4th remaining in the numerator. The next problem, there are a few different ways to work through it. What I found helps me on a problem like this is to simplify the inside part as much as I can first. So here, 18 divided by 6 is 3. B to the negative 4 divided by B to the negative 3. We subtract the exponents, negative 4 minus negative 3. We would have B to the negative 1. C to the 7th divided by C squared. We take 2 away from 7. We would have C to the 5th. And now we have all of this raised to the negative 4. So here we would have then 3 to the negative 4, B to the negative 1 to the negative 4, and C to the 5th to the negative 4. 3 to the negative 4 would be 1 over 3 to the 4th. And 3 to the 4th is 81. So we'll have an 81 in the denominator of our answer. The next portion, multiply the outside exponent by the inside exponent. Negative 1 times negative 4 is a positive 4. We would have a B to the 4th in the numerator. Multiply the outside exponent by the inside exponent in the next portion. We would have C to the negative 20th, which will give us C to the 20th in the denominator of our answer.